Okay, so the first question of this paper says that given that we have the equation 2 to the power of x times by 4 to the power of y is equal to 1 over 2 root 2, express y as a function of x. And this is a 3-mark question. So what we need to do is express y as a function of x. And we can see that the values y and x happen to be in the powers of some of the values in this equation. Now, generally, when you're asked to solve an equation where the variable is in the powers, you really want to try and find some way of bringing those powers down. So we might need to manipulate this equation in order to achieve that goal. Now, looking at the right-hand side, notice that we have 1 over a value, and that value is 2 root 2. Well, we can rewrite this value using one of the law of indices, which would bring the 2 root 2 to the same level as the terms on the left hand side. We can use our law of indices to rewrite the right hand side as follows. 2 to the power of x times by 4 to the power of y is equal to 2 times by root 2 to the power of negative 1. Now, by looking closely at the bases in this equation, you might be able to see that all of these bases can be written as a power of 2. Now, that's important because if each term has the same base, then that gives us an easy way to find an equation for the powers. Firstly, we know that 4 can be written as 2 squared, and 2 root 2 is equal to 2 multiplied by 2 to the power of a half. And shortly we're going to see that this is also a power of 2. Okay, so therefore we get that 2 to the power of x times by 2 squared, all raised to the power of y, is equal to 2 times by 2 to the power of a half, all raised to the power of negative 1. Using the law of indices, we can multiply these two values inside the brackets, which have the same base, by adding the powers. And therefore, 2 to the power of x times by 2 squared raised to the power of y is equal to 2 to the power of 3 over 2, because a half plus a 1 here is equal to 3 over 2 raised to the power of negative 1. So we've just shown that the value 2 root 2 is also a power of 2. Let's now multiply the powers inside the brackets to the powers outside the brackets, giving us that 2 to the power of x times by 2 to the power of 2y is equal to 2 to the power of negative 3 over 2. So by using the law of indices, we've now just achieved an equation where we have the same base of 2 for each term. And this allows us to see that the sum of the powers x plus 2y, which we're allowed to do because we're multiplying terms which have the same base, is equal to the power on the right hand side, negative 3 over 2. So we're almost there. We now have a linear equation that we need to solve for y in order to express y as a function of x. So subtracting x from both sides of the equation, we get that 2y is equal to negative 3 over 2 minus x, and dividing both sides of the equation by 2, we get that y is equal to negative 3 over 4 minus x over 2. Question 2. The speed of a small jet aircraft was measured every 5 seconds, starting from the time it turned onto a runway until the time when it left the ground. The results are given in the table below with the time in seconds and the speed in meters per second. And here you can see the table. Using all of this information, part A asks us to estimate the length of the runway used by the jet to take off. And this is a 3-mark question. So this question gives us a table which shows the different
and here is where the error is, and it's one that's typically made by students
at different points in time. Now, if we look closely at the change in speed, we'll see that the relationship between speed and time is non-linear. From 0 to 5 seconds, the speed increases by 3 meters per second. From 5 to 10 seconds, the speed increases by 5 meters per second. From 10 to 15 seconds, the speed increases by 8. From 15 to 20 seconds, the speed increases by 10. And from 20 to 25 seconds, the speed increases by 14. So this shows a clear non-linear relationship between the speed and the time. If speed was proportional to time, then you would get away with ignoring all of these values and just using the final speed and the total time taken. But this is not linear, so we need to choose a method that considers these changes in speeds. Let's draw a curve showing this relationship between speed and time. Now, as we know that speed equals distance divided by time, it follows that the distance is equal to the speed times time. And in this case, that would represent the area underneath this graph. Now, because this graph is not linear, it makes the question less straightforward. But since the time has been spaced out in equal intervals, and we know the value of speed at different times, that means that we can use the Trapezium Rule to find an estimate for the area underneath this graph. So let's split this into equal partitions. We can then use the Trapezium Rule, and here is a formula which will be provided in your formula booklet. So using this formula, we need to find h, where h is equal to b minus a over n. Now in this question, a would be equal to our first value of time, so it would be equal to 0. B would be equal to our last value of time, which would be equal to 25. And n here is equal to the number of partitions, or the number of trapezium. There are 1, 2, 3, 4, 5 trapeziums, and therefore n is equal to 5. Be careful not to make the mistake of just counting the number of values there are, which is a mistake that a lot of students make. If you do want to count the number of values, then make sure you subtract it by 1, okay? Otherwise, if you have a sketch of the graph, just count the number of trapeziums you have, okay? So subbing these values into this formula, we get that h is equal to 25 minus 0 over 5, which is equal to 5. Next we need y0. y0 is the first y value given in the table, so y0 is equal to 2. And y sub n is the last y value that's given in the table. So y sub n is equal to 42. So now we have all the values that we need for the formula. If we let a be equal to the area under the graph, then using the formula, a would be approximately equal to a half times by 5. That comes from the half times the value of h that we found. And this would all be multiplied by y sub 0 plus y sub n, which is 2 plus 42 plus 2 multiplied by the sum of all of these values. And all of these values here are just the remaining y values in the table. So plus 2 times by 5 plus 10 plus 18 plus 28. And this is equal to 5 over 2 all multiplied by 44, which is 2 plus 42, plus 2 times by 61, which is the sum of all of these values. And this is equal to 5 over 2 times by 166. And if you work this out, this is equal to 415. And therefore, the length of the runway used is approximately equal to 415 meters. The last part of the question says, given that the jet accelerated smoothly in these 25 seconds, explain whether your answer to part A is an underestimate or an overestimate of the length of runway used by the jet to take off. And this is a 1 mark question. Our answer to part A is going to be an overestimate, because if we look closely at one of these strips, the actual area underneath this curve is going to be less than the area of the trapezium. And here you can see the dotted line goes over the curve. So the area is going to be greater. So we'll say that the answer in part A is an overestimate because the trapezia lie above the curve. On to question 3. So we're given figure 1 here, which shows a sector AOB of a circle with center O. It's got a radius of 5 centimeters and an angle AOB equal to 40 degrees. The attempt of the student to find the area of the sector is shown below. Part A asks us to explain the error made by the student. And this is a 1 mark question. So going through the student's calculations line by line, we see that the student has written that the area of a sector is equal to a half r squared theta, which is correct. The student then substitutes the value of r is equal to 5 and theta is equal to 40. And here is where the error is, and it's one that's typically made by students. When you use the formula half r squared theta to find the area of a sector, you must ensure to convert from degrees into radians. So the error that the student has made is that the student did not convert from degrees into radians. Okay. Part B asks us to write out a correct solution, and this is 2 marks. So as we've identified the error, we know that what we need to do is convert 40 degrees into radians before substituting it back into this formula. Now you are expected to know that 1 degree is equal to pi over 180 radians, and therefore 40 degrees is equal to 40 times pi over 180. We can cancel down these 2 terms as follows to get 2 over 9, giving us that 40 degrees is equal to 2 over 9 pi radians. So now we've converted 40 degrees into radians, we can substitute this value back into this formula to get that the area of the sector is equal to half times by the radius squared, 5 squared, times by 2 pi over 9. Here we see that the 2's cancel, and this leaves us with 25 pi over 9 centimeters squared, which you can leave in this form or provide the decimal equivalent answer. Question 4. The curve C1 with parametric equations x is equal to 10 cosine of t and y is equal to 4 root 2 sine of t for values of t between 0 and 2 pi meets the circle C2 with the equation x squared plus y squared is equal to 66 at 4 distinct points as shown in figure 2. So here we can see the 4 distinct points where the curves C1 and C2 meet. Given that one of these points, S, lies in the 4th quadrant, find the Cartesian coordinates of S. So S is one of the 4 points where the curves C1 and C2 meet, and we've been told that it lies in the 4th quadrant. Now, they've been very kind enough in this question to show us exactly where this point lies, but you should remember where your quadrants are. This is the 1st quadrant, the 2nd quadrant, the 3rd and the 4th. Now we've been asked to find the Cartesian coordinates of S. Now my little hack around remembering what Cartesian is, well, assuming I know that parametric equations always have a 3rd variable, and it's commonly t. Sometimes you see it as theta, sometimes you see it as other variables, but it is commonly t. Now the way I like to remember the word Cartesian is we get rid, that's what the R represents, of t. Okay, so by them asking us to find the Cartesian coordinates of S, we are looking for the x, y coordinates after we have gotten rid of t. Okay, so that's what we're after, the x, y coordinates of the point S. Now this is a 6-mark question, but we're not going to panic. We need to find the xy coordinates of this point S, and it happens to be where the 2 curves C1 and C2 intersect. Now there are many ways of doing this, but the way I like to do this is by working specifically with Cartesian equations. Okay, now we see that we've been given C2 in Cartesian form. X squared plus y squared is equal to 66. All that means is that there are 2 variables in the equation. However, we notice that the curve C1 has been given in parametric form. So we first need to convert this into Cartesian form in order to solve the simultaneous equation between the 2 curves that will give us the xy coordinate of S. So given this parametric equation for the curve C1, we need to convert this into Cartesian form. In other words, find a way of getting rid of the variables t. Now noticing that we have trigonometric functions inside this parametric equation, we can do the following. If we divide both sides of this equation by 10, we get that x over 10 is equal to cosine of t, and if we divide both sides of this equation by 4 root 2, we'll get that y over 4 root 2 is equal to sine of t. And as we now have an expression for cosine of t and an expression for sine of t in terms of x and y, we can use our famous Pythagorean identity sine squared of t plus cosine squared of t is equal to 1 in order to eliminate the variable t. So how do we do this? Well, if we square both of these equations, we're going to end up with sine squared t and cosine squared t. And if we add them together, the result should be 1 based on our Pythagorean identity. So squaring both of the equations and adding them, we get the following: x squared over 10 squared plus y squared over 4 root 2 squared is equal to 1. Evaluating the values in the denominator, we get that x squared over 100, which is 10 squared, plus y squared over 32, which is 4 root 2 squared, is equal to 1. We've now already converted the curve C1 in Cartesian form because, as you can see, we've gotten rid of the t. But let's just tidy this up so that we can make it easier to work with when we are solving the simultaneous equation of the curves C1 and C2. So adding these two fractions, in order to achieve a common denominator, we can simply multiply top and bottom of this fraction by 32 and the top and bottom of this fraction by 100, which will then allow us to add the numerators and get the following: 32x squared plus 100y squared over 3200 is equal to 1. Multiplying both sides by 3200, we get that 32x squared plus 100y squared is equal to 3200. And let's just label this equation 1. So now we have a nice Cartesian equation which represents the curve C1. We can find out the points of intersection between C1 and C2 by solving the simultaneous equation of this equation and this equation: x squared plus y squared is equal to 66. And we're going to do this by the process of substitution. So given this equation for C2, we can therefore say that y squared is equal to 66 minus x squared. So we've just subtracted x squareds from both sides of the equation. And let's label this equation 2. Now, as we have now found an expression for y squared, we can substitute this back into equation 1 to get the following: 32x squared plus 100 times by 66 minus x squared, so we've just substituted this for y squared, is equal to 3200. Multiplying out the brackets, we get that 32x squared plus 6600 minus 100x squared is equal to 3200. And collecting like terms on the left hand side and subtracting both sides of the equation by 6600, we're going to get negative 68x squared is equal to negative 3400. Now if we divide both sides of the equation by negative 68, we get that x squared is equal to 50. Now we're almost there. To find x, we simply need to take the square root of both sides, giving us that x is equal to plus or minus the square root of 50. I can't stress enough how much it's important never to forget that whenever you square root a term, it's always a positive and negative, and then you assess which value you're taking, whether it's one or the other or both. Okay? Now based off of this question, we know the point S lies in the fourth quadrant. Okay? So the value of x must be positive, and therefore we're going to take x as equal to positive square root of 50. Now in order to find the corresponding y value, we're going to substitute positive root 50 into this equation to get the following: that y squared is equal to 66 minus the square root of 50 all squared. And therefore y squared is equal to 66 minus 50, which gives us that y squared is equal to 16. Taking the square root of both sides, we get that y is equal to plus or minus 4. Now as this is in the fourth quadrant, you can quite clearly see that the value of y would be negative, and therefore we take the negative version of y. And therefore the Cartesian coordinate of s is equal to the square root of 50 and negative 4. Okay. Question 5. Figure 3 shows a sketch of the curve with the equation y is equal to the square root of x. The point P with coordinates xy lies on the curve. The rectangle shown shaded on figure 3 has a height of y and a width of delta x. We've been asked to calculate the sum from x equals to 4 to 9 of the square root of x delta x, taking the limit as delta x goes to 0. So let's look at figure 3. So here we have the graph y is equal to the square root of x, we have a rectangle which has a width of delta x as we're told, and it has a height of y. And this rectangle touches the curve at the point P, which has a coordinate x, y, which just means that the height y is the value of the function y equals the square root of x evaluated at the point x. Now, given this information, we need to work out what this sum is, and it looks rather complicated, but let's try and break it down. Looking at this term here, we have the square root of x times by delta x. Now we know that delta x represents the width of the rectangle, and it's being multiplied by the square root of x. Now the square root of x is equal to y, which was the height of the rectangle. So if we have a rectangle with a width of delta x and a height of the square root of x, then that means that the area of a rectangle is going to be equal to the square root of x delta x. So we know that this is the area of the rectangle. Then looking here, it's asking us to take the sum from x equals to 4 to 9. So we can interpret this that it's asking us to take the sum of rectangles from x equals 4 to 9. And if we took the sum of rectangles of the same width delta x, it would look something like this. We would be adding up the areas of all of these rectangles. Now looking at this sum would be close to the area under the curve from x equals 4 to 9. But if we look closer, we can see that it's not going to exactly be equal to the area under the curve, and that's because the curve goes over the rectangles. But consider the last part, which asks us to take the limit as delta x goes to 0. What does that mean? And how will this affect our calculation? This is the same as making the width of these rectangles smaller and smaller and smaller. And interestingly, if we were to reduce the width of each of these rectangles, we would need to increase the number of rectangles that span this region. And if we continue to reduce the width, what you'd see is that the rectangles would be getting closer and closer to the curve until the point where it completely fills the region bounded by the curve and the x-axis. So taking the limit as delta x goes to 0 is the same as finding the area underneath the curve, bounded by the limits 4 and 9. And since this curve represents the function y equals the square root of x, that means that we can solve this problem by integration. And therefore the sum from x equals 4 to 9 of the square root of x times by delta x, taking the limit as delta x goes to 0, is equal to the integral from 4 to 9 of the square root of x with respect to x. Integrating this term, the square root of x, we get 2 over 3 times x raised to the 3 over 2. And we need to evaluate at these limits. So we need to substitute 9 into this integral to get 2 over 3 times by 9 raised to the 3 over 2 minus 2 over 3 times by 4, the other limit, raised to the power of 3 over 2. Working this out, this is equal to 54 over 3 minus 16 over 3, which is equal to 38 over 3 units squared. Question 6. So figure 4 shows a sketch of the graph y is equal to g of x, where g of x is equal to x minus 2 all squared plus 1 for values of x less than or equal to 2, and 4x minus 7 for values of x strictly greater than 2. Part A asks us to find the value of gg of 0, and this question is 2 marks. So first of all, we can see that g of x is a piecewise function, which is basically a function that it's made up of multiple subfunctions. And you can see that this is illustrated quite nicely on the diagram, which we can call g of x. On the left, we have our quadratic function for values of x less than or equal to 2. And for all values of x strictly greater than 2, we have this linear function 4x minus 7, which would be to the right side of this point 2 here. Okay. In order to find gg of 0, we first of all need to evaluate the inner function, which is the function of g evaluated at 0. It's important to look at the domain in order to determine which subfunction we need to substitute our value into. Now, as x equal to 0 is less than 2, then
this is a subfunction that we need to substitute x is equal to 0 into. X minus 2 all squared plus 1.
Okay, so gg of 0 is equal to g of 0 minus 2 all squared plus 1. And calculating the value inside of the square brackets, we get that gg of 0 is equal to g of 5. Now to finish off this question, we need to evaluate the function of g at 5. Looking at our domain, since 5 is a value of x which is greater than 2, it means that we need to substitute 5 into this function. And therefore g of 5 is equal to 4 times by 5 minus 7, which is equal to 13. Part B of this question says find all the values of x for which g of x is strictly greater than 28. And this is a 4-mark question. Now let's take a step back and think about this visually first, because by asking us to find all the values of x for which g of x is greater than 28, this question is asking us where is the region where the graph or the function is greater than 28, and what are the x values that produce that region. Now earlier on I mentioned that this point here is clearly going to be the point 2. Now why? Well, it's quite clearly the point where the piecewise function changes from a quadratic curve to a straight line, and can be confirmed by looking at the domain. Okay, now if we were to work out the corresponding y value of x is equal to 2, well, because x is only allowed to be equal to 2 when we're looking at this function, the quadratic, so we'll have to substitute x equal to 2 into this function to give us 2 minus 2 all squared, so 2 minus 2 is 0, all squared is 0 plus 1. So that gives us a corresponding y value of 1. The reason why I've done this is because I just want to get a feel for where the value 28 is on this graph. Okay, so since this is 1, we can assume that 28 is somewhere quite well above 1. Okay, so as I mentioned before, we're trying to figure out the region or the x values that give me y values which are greater than 28. Okay, now if we map this value of y is equal to 28 back onto the graph, there would be two corresponding x values, one here and one here, showing that there are two x values when y is equal to 28. But we're not after the x value where y is equal to 28, because we've been asked to find the x values where y is greater than 28. And y is greater than 28 at these points in the function, here and here, which would be produced by x values as shown in the diagram. So these points would still be important for us because they're going to act as bounds for what we can visually see as a disjointed set of x values. Please note that for the purpose of explaining this to you, I have drawn these intervals with a closed circle, but because we're looking for where the function is strictly greater than 28, this should be drawn with open circles. Okay, so what we need to do to solve this problem is find the set of these x values that satisfy this inequality. Let's go ahead and start with this set. So we can find out this set by working out where the quadratic function is greater than 28. In other words, where x minus 2 all squared plus 1 is strictly greater than 28. Now, solving quadratic inequalities aren't always as straightforward because it's important you know the region that you're looking at, but we've already done the hard work in deducing where that region would be. It would be all values to the left of this critical point. So let's figure out the critical point or the critical value by setting this as an equation. Okay, so instead let's solve this as an equation. X minus 2 all squared plus 1 is equal to 28. Subtracting 1 from both sides, we would get x minus 2 all squared is equal to 27. If we take the square root of both sides, we'll get that x minus 2 is equal to plus or minus the square root of 27. And if we add 2 to both sides of the equation, we get that x is equal to 2 plus or minus the square root of 27. Now, this critical value is clearly on the negative x-axis, and therefore 2 plus the square root of 27, we can exclude that as a value, as that's a positive number. Instead, we'll use 2 minus the square root of 27, but I'm still going to double check that this is indeed a negative number, as you should always be looking to double check in your exam. Okay, so let's just type in 2 minus the square root of 27 and press the SD button, and that's equal to a negative value. Okay, therefore we can conclude that the critical value is equal to 2 minus the square root of 27. And let's just update this on the diagram. So now we have our critical value. We can deduce that the set of x values which satisfy this inequality on this side is the set of x values strictly less than 2 minus the square root of 27. Now let's work out the other set of values, and this can be found by solving the following inequality. 4x minus 7 is greater than 28. We can solve this right away by adding 7 to both sides, giving us that 4x is greater than 35, and if we divide both sides of the inequality by 4, we get that x is strictly greater than 35 over 4, giving us the other set of values that satisfy this inequality. And I'll just add 35 over 4 to this diagram just to complete everything. And now we have both of our disjointed sets. We can conclude that therefore the set of x values that satisfy this inequality is the set of x values less than 2 minus the square root of 27, and because they are disjointed we must use the word or, the set of x values strictly greater than 35 over 4. The next part of the same question says that the function h is defined by h of x is equal to x minus 2 all squared plus 1 for values of x less than or equal to 2. Part C asks us to explain why h has an inverse but g does not, and this is a 1 mark question. We already know that this is the function g of x, and h of x has been defined to be the quadratic function x minus 2 all squared plus 1 only for values less than or equal to 2. So that will be represented by this portion of the graph. Okay, and we'll just put 2 here. And let's just label this y is equal to h of x. Alright, so the question is, why does h have an inverse but g does not? Well, in order for a function to have an inverse, it must be a one-to-one function or mapping. And you can test if a function is one-to-one by simply conducting the horizontal line test, which means that if you're able to draw horizontal lines going all the way through your graph, and there's only one point of intersection between the graph and the lines you've just drawn, then that means that it's a one-to-one function and therefore has an inverse. So h has an inverse because it's a one-to-one function. However, g does not, because if we extend these lines, we'll see that there are more than one point of intersection between the graph g of x and the horizontal lines we've just drawn. Okay, so here we have 2 points of intersection, here we've got another 2 points, etc. Okay, so the reason why h has an inverse but g does not is because h is a one-to-one function, but g of x is a many-to-one function. Okay, part D says solve the equation h inverse of x is equal to negative a half, and this is for 3 marks. So in order to solve this equation, we need to find a way of making x the subject of this equation. So some of you might remember that if you have a function, say f of x, and it has an inverse, the way to find x is to apply its inverse to itself. Okay, so using this fact here, if we apply h to both sides of this equation as follows, we would get h of h inverse of x is equal to h of negative a half. We've just seen that this side would be equal to x, and all we have to do now is evaluate the function h at negative a half. So substituting negative a half into this function h of x, we are going to get x is equal to negative a half minus 2 all squared plus 1, and evaluating this term, negative a half minus 2 is equal to minus 5 over 2, and therefore we get x is equal to minus 5 over 2 all squared plus 1, and evaluating this term we get that x is equal to 7.25. Question 7. A small factory makes bars of soap. On any day, the total cost to the factory, y, given in pounds, of making X bars of soap is modelled to be the sum of two separate elements, a fixed cost and a cost that's proportional to the number of bars of soap that are made that day. Part A asks us to write down a general equation linking y with x for this model. So we know that y, the total cost to the factory to make these bars of soap, is made up of the sum of two parts, one being a fixed cost and another being a different cost which is proportional to the number of bars of soap. So one part of the equation is quite easy because it's the fixed cost. So if we let C be equal to the fixed cost, then we just need an expression for this other cost in terms of x in order to complete an equation linking y and x. Now, if we just call this other cost D, knowing that it's proportional to the number of bars of soap, which is x, we can write this expression, D is proportional to x. And you should know that if D is proportional to x, then therefore D is equal to k times by x, where k is generally a constant to be found. So as we now have an expression for this other cost in terms of x, we can add it to the equation of y to give us that therefore y is equal to c, the fixed cost, plus k times x, where k is a constant, okay? On a day when 800 bars of soap are made and sold, the factory makes a profit of £500. On a day when 300 bars of soap are made and sold, the factory makes a loss of £80. Using the above information, part B asks us to show that y is equal to 0.84x plus 428, and this is a 3-mark question. In the previous question, we were able to find a general equation linking y with x. Now, just comparing this with what we've been asked to show, you should be able to see that they're asking us to find a value for c and a value for k. And this is now possible given what we've just been told in this part. And just as a side note, in exams, when you're given two sentences with facts and values and you're trying to find an unknown, you should already be thinking about simultaneous equations. But how do we generate a simultaneous equation using these facts? Well, we've been given the profit, we've been given the loss, we've been given the number of bars sold in each case and the price of selling each bar. So that means that on each day we can work out the amount of money we would make from sales by multiplying the number of bars sold on that day by the price they're sold for. Now, you are required to be able to know that the profit is equal to the sales, the amount of money that's made from sales, minus the total cost. So let's use this equation to generate some more equations from these facts, starting with the first one. So we're told that the factory makes a profit of £500. The sales on that day would be equal to the number of bars sold, 800, multiplied by the price they're sold for. So 2 times by 800. And the total cost, well, we already have an expression for the total cost, which is c plus k times by x. However, we haven't been given what the fixed cost is, and we also don't know this constant k. However, we do know how many bars of soap were made that day, which was 800 bars. And therefore, in order to complete this equation, we need to subtract the total cost, which would be minus c plus 800, the number of bars made, multiplied by k, the constant. Now let's just multiply these values and expand the bracket to get that 500 is equal to 1600 minus c minus 800k. And if we subtract both sides by 1600, we get that minus 1100 is equal to minus c minus 800k. And I've just labeled this as equation 1. We're then told that on another day, the factory makes a loss of £80. Now, a loss is just negative profit. So a loss of £80 can be represented as negative 80. And that's going to be equal to the sales, which would be 300, the number of bars sold, times by 2. 2 times 300. minus the total cost, where we would use this expression, which represents the total cost, but the number of bars made on that day was 300, and therefore we would have minus C plus 300k. Multiplying this value and expanding out the brackets, we get that therefore minus 80 is equal to 600 minus C minus 300k. And subtracting both sides by 600, we get minus 680 equals minus C minus 300k, and I've labeled this equation 2. So we now have two equations and two unknowns being C and K, which means that we can solve this. So I'm going to use a process of elimination to solve this equation, and I'm going to first of all eliminate the variable C by doing equation 1 minus equation 2, because that gives us minus C minus minus C, which is minus C plus C, which is equal to 0. So doing equation 1 minus 2, we get minus 420 is equal to minus 500k, and do check these calculations I've done here. In order to find k, we divide both sides by negative 500 to get that k is equal to 21 over 25, or 0.84. In order to find c, we substitute this value into any of the equations. I'm going to choose equation 1, and that gives us minus 1100 is equal to minus c minus 800 times by this 0.84. Multiplying out the brackets on the right hand side, we get that minus 1100 is equal to minus c minus 672, and therefore c is equal to 428. So now we found our values for c and k. We can substitute it back into our general equation to show, as required, that y is equal to 0.84x plus 428. Okay. Part C says, with reference to the model, interpret the significance of the value 0.84 in the equation. Now this is the typical type of interpretation question that you'll see in pure and applied questions when you're looking at a linear model or a linear equation, and they're generally only 1 mark. 0.84 is the number that gets multiplied by x, the number of bars of soap made. And in a more general sense, this x is the independent variable. And in maths, we're always interested with what happens to the output of a function when the independent variable increases or decreases by 1 unit. So just looking at the equation, if we increase the independent variable x by 1, the value of this equation increases by 1 times by 0.84, which is 0.84. So the significance of this value 0.84 is that it represents the cost of making each extra bar of soap. So try to remember and understand how we look at these types of questions generally, but you do need to put your interpretation into context in order to get the mark, okay? The next part of the question says, assuming that each bar of soap is sold on the day that it is made, find the least number of bars of soap that must be made on any given day for the factory to make a profit that day. So we already know the definition of profit being equal to the sales minus total cost. And in order to make profit, this value must be greater than 0. Now, if we let n be equal to the least number of soap bars needed in order to make profit, then using this equation, we can say that the profit would be equal to the sales 2 times by n, which we've just defined as the least number of bars needed to make a profit, minus the total cost. We now know a complete expression for the total cost, but instead of x, we're going to use n. The reason being is because it will take n number of bars to make a profit. And in order for this to be a profit, it needs to be greater than 0. Okay? So again, just looking at some keywords, when you see words like least, a technique that you should be thinking of is generally working with inequalities. All right? So now let's work out this value of n that we've just defined. If we expand the brackets on the left-hand side, we get that 2n minus 0.84n minus 428 is greater than 0. If we collect the like terms and add 428 to both sides, we get that 1.16n is greater than 428. And if we divide 1.16 by both sides, we get that n is greater than 368.96 and so on. So what this is saying is that any number of n greater than 368.96 and so on is going to give us a profit. The least or the smallest value of n that would give us a profit would be the nearest whole number greater than this value, and therefore n is equal to 369 bars. Question 8, part I. Find the value of the sum of terms from r equals 4 to infinity of the series 20 times a half raised to the power of r. And this is a 3-mark question. Now, whenever you're asked to find the sum of terms in a series, I would generally advise that you start to write down terms and try and see if you spot a pattern. Okay, so let's write the first term of this series. When r is equal to 4, the first term is equal to 20 multiplied by a half raised to the power of 4. The next term would be when r is equal to 5, which is 20 multiplied by half raised to the 5. The next term would be r equal to 6, and so on. By writing the first few terms of this series, hopefully you can see that the difference between the terms is a multiple or a common ratio of a half. And therefore this is a geometric series which has a first term, which we'll call a, equal to 20 times by a half raised to the power of 4. And the common ratio r would be equal to a half. Now, in order to find the sum of terms of a geometric series to infinity, we have a special formula that's in your formula book, given as the sum of terms of a geometric series to infinity is equal to a divided by 1 minus r, where a is the first term and r is a common ratio, for the modulus of r less than 1, which is values of r between -1 and 1. And just to confirm, r is equal to a half, which would fall within that range. So we can use this formula. So as we know what the first term and the common ratio is, we can substitute these values into this formula to work out the sum to infinity of this series. So therefore, the sum to infinity is equal to the first term, 20 multiplied by a half raised to the 4, divided by 1 minus the common ratio, 1 minus a half, which if you put into your calculator is equal to 1.25 over 0.5, giving us an answer of 2.5. Okay. The next part says show that the sum of series from n is equal to 1 up to 48 of log base 5 of n plus 2 over n plus 1 is equal to 2. So here we need to show that the left hand side, which is a sum of series, is equal to 2. Now, just as we did in the previous question, whenever you're given these types of questions where we need to take the sum of a series or evaluate a sum of series, I'd always recommend that we start writing out the first few terms and see if we notice a pattern. Okay, so let's start with the first term of this series. When we substitute n equals to 1 into this expression, we get log base of 5 of 1 plus 2, which is 3 in the numerator, over 1 plus 1, which is 2 in the denominator, giving us a first term of log base 5 of 3 over 2. When we sub n equals 2 into this expression, we get log base 5 of 2 plus 2 over 2 plus 1. So we get log base 5 of 4 over 3. Subbing n equal to 3 into this expression, we get log base 5 of 5 over 4. And if we keep substituting terms all the way up to n equals to 48, we get log base 5 of 48 plus 2, which is equal to 50, over 48 plus 1, which is equal to 49 in the denominator. Now, on face value, we can kind of see a pattern between these terms. Firstly, we can see that the numerator is always 1 plus the denominator for each of these terms inside the argument, and the numerators are consecutively increasing by 1 and the denominators are consecutively increasing by 1. So the first thing I would generally tend to do is ask myself, is this one of the main sequences that we've studied at A level? Is it an arithmetic sequence? Well, if you subtracted consecutive terms from each other using a calculator, you would see that the difference isn't constant and therefore it's not an arithmetic. Is it a geometric? Well, if you were to divide consecutive terms, you would find that there wouldn't be a common ratio and therefore it isn't geometric. Is it periodic? Well, there are no repeating terms in this sequence and therefore it's not periodic. Is it a constant sequence? Well, it's clearly not a constant sequence because none of the terms are the same. But by understanding the law of logarithms, we can make this question a lot easier for ourselves by simplifying the right hand side. Now notice that for each term we have a log which has the same base of 5, and in each case we are adding the logs. So we're adding logs of the same base. What does this remind you of? The addition, or some refer to as a multiplication law of logarithms. So using this law, that means we can multiply the arguments of this log. So using this law, we can take log base 5 of the multiple of the arguments of terms in this series. And what I mean by arguments is just the values inside the brackets. So this is equal to log base 5 of 3 times 4 times 5 up to 50 divided by 2 times 3 times 4 up to 49. And thankfully there is some cancelling that we can do inside of the brackets. You'll notice that the 3's cancel, the 4's also cancel, and in fact every value in this multiple cancels apart from the 50 and the 2. Okay? And therefore this is equal to the log base 5 of 50 over 2, which is equal to 25 in here. Now let's just work out what this value is in our calculator. So log base 5 of 50 over 2, which is 25. And that's equal to 2 as required. Okay. Question 9. A research engineer is testing the effectiveness of the braking system of a car when it is driven in wet conditions. The engineer measures and records the braking distance, d meters, when the brakes are applied from a speed of v kilometers per hour. Graphs of d against v and log base 10 of d against log base 10 of v were plotted. The results are shown below together with a data point from each graph. So here we have figure 5 showing a non-linear graph of d, the braking distance, against v, the speed, and we've been given a point with coordinates 30 and 20. And for figure 6 we have a linear graph with log base 10 of d against log base 10 of v, and we've been given the coordinates 0 and minus 1.77 on the graph. Part A asks us to explain how figure 6 would lead the engineer to believe that the braking distance should be modelled by the formula d is equal to k times v to the power of n, where k and n are constants, with k being approximately equal to 0.017. And this is for 3 marks. So we need to find a way to show how figure 6 would lead the engineer to believe that the braking distance should indeed be modelled by this formula d equals k times v to the power of n. And we need to show that k would be approximately equal to 0.017 using figure 6. Now this is a non-linear equation, and we can often use logarithms to get more information about the variables and constants you can find inside non-linear equations. So let's take the log of both sides of this equation. For the sake of figure 6, we're going to purposely take the log base 10 of both sides. So therefore log base 10 of d is equal to log base 10 of k times v to the power of n. Using the addition or the multiplication law of logs, we can split the right hand side into a sum of logs as follows. So we get log base 10 of d is equal to log base 10 of k plus log base 10 of v raised to the power of n. And using the power law, we can bring the power of n down, giving us the following. Log base 10 of d is equal to log base 10 of k plus n log base 10 of v. So by using logs, we've managed to convert this non-linear equation into a linear one. And that means that we can compare this with any linear relationship. But before we do that, let's just compare this with the general equation for a straight line, y is equal to mx plus c, just so we know what each of these parts would represent in a linear equation. So Let's start off with our variable, starting with y. So the y part of this, hopefully you can clearly see it would be equal to log base 10 of d. The x part, well, that's going to be the other variable in the equation. So the other variable, as we're told, k and n are constants, and so v is the other variable, and therefore log base 10 of v would be equal to the x part. Looking at m, our gradient, well, that's going to be equal to the value which is multiplied by the variable, and in this case that would be n, as we have here, n equals to m. So that leaves us with log base 10 of k is equal to c. So by comparing these terms with the general equation for a straight line, we've managed to show that log base 10 of d would be the y part of this equation, and if we look at figure 6, it happens to be the y part of this graph, and log base 10 of v is equal to the x part of the equation, and here we can see that log base 10 of v is the x part of the graph. So we can compare this linear relationship with the linear relationship represented by this graph to help us find out what the value of k is in this question. And the one thing we can use is this point here, the y-intercept, or c, which is equal to negative 1.77, and therefore we can say that log base 10 of k is equal to negative 1.77. Now, in order to solve for k, we can use one of the rules you can use to solve logarithms. I like to call this the anti-clockwise law, because we start from the base and we go anti-clockwise. We say 10 raised to the power of negative 1.77 is equal to k. Okay, and therefore we have 10 raised to the negative 1.77 equal to k. Evaluating this in our calculator, we get that k is equal to 0.0169 and so on, which is approximately equal to 0.017 as required. So let's just round this off with a closing statement. By using the linear relationship shown in figure 6 with a y-intercept equal to negative 1.77, we showed that the braking distance should indeed be modeled by the formula d is equal to k times by v raised to the n, with k approximately equal to 0.017 as shown. The next part of the question says, using the information given in figure 5 with k equal to 0.017, find a complete equation for the model giving the value of n to 3 significant figures. So in order to find a complete equation for this model, we're going to substitute k, which has been given as 0.017, into this formula, and we're then going to substitute the coordinates given in figure 5. So for this coordinate we have v equal to 30 and d equal to 20. So subbing these values, we get that 20 is equal to 0.017 multiplied by 30 raised to the power of n. Dividing both sides by 0.017, we get that 1176.47 and so on is equal to 30 raised to the power of n. In order to find n, we need to take the log of both sides, bring the power down. So taking the log of both sides, we get that log of 1176.47 and so on is equal to n log 30, and we've used the power law to bring the n down there. And therefore n is equal to the log of 1176.47 and so on divided by the log of 30. And you must not round any of your values in these types of questions until the end, okay? Calculating this in our calculator, we get that n is equal to 2.078 and so on, which is equal to 2.08 to 3 significant figures. And therefore the complete equation for this model is d is equal to 0.017 multiplied by v raised to the power of 2.08. The next part of this question says, Sean is driving this car at 60 kilometers per hour in wet conditions when he notices a large puddle in the road 100 meters ahead. It takes him 0.8 seconds to react before applying the brakes. The question says, use your formula to find out if Sean will be able to stop before reaching the puddle. And this is another 3-mark question. So for this question, we need to work out the total distance traveled from the moment that Sean realizes that there's a large puddle 100 meters ahead to the moment he completely stops. If this distance is less than 100 meters, then we know that Sean will be able to stop before reaching the puddle. And if the distance we find is greater than 100 meters, then we know that Sean won't be able to stop before reaching the puddle. Now notice that this distance can be split up into two separate distances. One we can call the thinking distance. Now we're told that it takes him 0.8 seconds to react before applying the brakes. So there would be a distance that he travels before he applies the brakes. And there would of course be the braking distance, which would be the distance he travels from the moment he applies the brakes to the moment he completely stops. Now let's start this problem by working out the thinking distance. So we're told that Sean is driving at 60 kilometers per hour and it takes him 0.8 seconds to react before applying the brakes. So from these values we can calculate the thinking distance using our famous formula: speed is equal to distance divided by time. However, we've been given the speed here in kilometers per hour and we need to work out the distance in meters. Now we've also been given his thinking time in seconds. So in order to find the distance in meters, it would be much easier if we convert the speed given in kilometers per hour into meters per second. Okay, so given the fact that we know from our conversions that 1 kilometer is equal to 1000 meters and that 1 hour is equal to 60 times by 60 seconds, therefore 60 kilometers per hour is equal to 60 times by 1000 meters, which is 60,000, divided by 60 times 60 seconds, which is 3,600. And if you ever do forget your formulas, remember that the units of measurements for some of these values can help you to make these conversions. For example, kilometers is multiplied by 60, so we multiply the 60 times 1000, and then we divide by hours. So the units of measurements are also useful for calculations. So now working out this value is equal to 16.6 recurring meters per second. So now we have the speed in meters per second. We can use this formula to work out the distance in meters by multiplying the speed by the time, which was 0.8 seconds. So therefore the thinking distance is equal to 16.6 recurring multiplied by 0.8. And just again a note on the units, if we were to multiply the units of meters per second for this value to the units of seconds for this value, you would get cancelling of the seconds, leaving you with just meters, and then you know you've done the right calculations. Okay. And so working this out in our calculator, we would get that the thinking distance is equal to 13.3 recurring meters. So now let's work out the braking distance. Now in the question we were told to use the formula to find this total distance. So let's use the formula that we worked out in the earlier problem of d is equal to 0.017 times by v raised to the power of 2.08. Now if you use the unrounded values, that would also be fine, but I'm just going to use the rounded values. So all we need to do is substitute v, the speed, into this formula to work out the distance. Now always just checking the units. In the first part of the question we saw that the braking distance d in meters is calculated from this formula at speeds of v kilometers per hour, and therefore we are rightfully allowed to substitute speed in kilometers per hour. So subbing the speed that Sean was driving at, which was 60 kilometers per hour, we get that therefore the braking distance is equal to 0.017 multiplied by 60 raised to the power of 2.08. Subbing this in our calculator, we get 84.91 and so on meters. So we now have the thinking distance and the braking distance. So therefore the total distance travelled after noticing the puddle is equal to 13.3 recurring plus the 84.91 and so on meters that we've just found. And that's equal to 98.25 and so on meters. And since this value is less than 100 meters, we can conclude that Sean will be able to stop before reaching the puddle. Question 10. Figure 7 shows a sketch of a triangle OAB. The point C is such that the vector OC is equal to 2 times the vector OA. The point M is the midpoint of AB. The straight line through C and M cuts OB at the point N. Given that the vector OA is equal to A and the vector OB is equal to B, the first part asks us to find the vector CM in terms of A and B. And that's for 2 marks. So before solving any of these problems, I always find it super useful to label the diagram as completely as possible with the provided information. So we're told that the vector OA is equal to A, and therefore let's just label that here. We're told that the vector OB, O to B, is equal to B, so we're just going to label this. We're told that the point C is such that the vector OC is equal to 2 times the vector of OA. So that means that there'll be a point around about here where the vector O to C would be twice the vector O to A. We're also told that M is the midpoint of AB, so we'll just label that here. And we're then told that the straight line through C and M cuts OB at the point M. So there's going to be a straight line which goes through C and M, which cuts this line OB at the point N. So the first part wants us to find the vector C to M in terms of A and B. Now in order to do this, we need to try to find some other way of expressing the vector C to M using other vector paths. Now another way you can go from C to M is to go from C to A and then from A to M. So therefore we can write that the vector C to M is equal to CA plus A to M. Now we know that M is the midpoint of the vector A to B, and therefore we can express the vector A to M as half of the vector A to B, giving us that C to M is equal to CA plus half AB. Now what's the vector CA? Well, as we know that the vector OC is 2 lots of the vector OA, well that means that this part here, the magnitude of this part would be A, and the vector A to C would be going in this direction. And therefore C to A would be going in the other direction with the same magnitude. And so CA is negative A. Now in order to find half of AB, we first of all need to know how to get the vector AB. And to get the vector AB, we need to go from A to O, which is going backwards, which gives us minus A, plus O to B. And therefore this vector can be written as half B minus A. Okay, expanding out the brackets, we get that this is equal to minus A plus a half B minus a half A. And collecting the like vector terms, we get that CM is equal to negative 3 over 2A plus half B. The next part says show that the vector ON is equal to 2 minus 3 over 2 lambda all multiplied by the vector A plus half lambda B, where lambda is a scalar constant. And this is another 2-mark question. Now we need to find a way to express the vector O to N. And of course there is the direct path from O straight to N, but my advice would be to always try and use a path which contains the most information. We don't know anything else about this direct path other than the fact that it's a fraction of the vector OB. Now another path we can choose is by going from O to C and then from C to N. And therefore we can say that the vector O to N is equal to O to C plus C to N. Now we can express this vector C to N in another way. Because the points C, M and N are on the same line, or you could say collinear, that means that the vector C to N is a scalar multiple of the vector C to M. So this is where we can start to involve this lambda that we need somehow in this question. Okay, so we could therefore write that this is equal to OC plus lambda CM, where lambda is a scalar multiple that we're going to use. Now, as mentioned before, we know that OC is equal to 2 times OA. Therefore, OC is going to be equal to 2A. And this part, well, CM, we just worked out. So this is going to be plus lambda multiplied by this vector minus 3 over 2A plus half B. Expanding the brackets, we get that this is equal to 2A plus negative 3 over 2 lambda A plus lambda over 2B. And we can collect like terms, these two terms here, giving us that this is equal to 2 minus 3 over 2 lambda multiplied by A plus lambda over 2B. And this is the same as what we've been asked to show. The last part says, hence prove that the ratio O to N to n to b is equal to 2 to 1, and this is for 2 marks. Now, in order to prove that the ratio O to n to b is equal to 2 to 1, from our ratios we should know that there are a total of 3 parts to this ratio, and therefore O to n would represent 2 out of the 3 parts of this ratio. So if we can prove that O to n is 2/3 of the line O to b, which represents all parts of this ratio, then we've proven that the ratio O to nb is equal to 2 to 1. Now, we've just shown a way to express the vector on in the previous question. It has an a and a b component. However, when we're looking at the direct vector path from O to n, notice that it wouldn't actually have an a component, and therefore we can say the a component of this vector is equal to 0. And so 2 minus 3 over 2 times by lambda is equal to 0. Adding 3 over 2 lambda to both sides of the equation, we get that 3 over 2 lambda is equal to 2. Multiplying both sides by 2, we get that 3 lambda is equal to 4. And dividing both sides by 3, we get that lambda is equal to 4 over 3. Now, as we've now found lambda, we can sub this value back into the expression to find a new expression for O to n in terms of b. So subbing this value, we get that on is equal to half times by 4 over 3 times the vector b. And remember, there is no a component, so this part would be equal to 0. So this is equal to 4 over 6b. Simplifying this fraction, we get that this is equal to 2 over 3b. And so if the vector O to n is equal to 2/3 of b, then the vector n to b must be the remaining part, which would be equal to 1/3 of b. So therefore we can conclude that the ratio of O to n to b is equal to 2 to 1. Question 11. Figure 8 shows a sketch of the curve C with the equation y is equal to x raised to the power of x for values of x strictly greater than 0. Part A asks us to find, by firstly taking logarithms, the x-coordinate of the turning point of C. And it says solutions based entirely on graphical or numerical methods are not acceptable. And this is a 5-mark question. So here we need to find the x-coordinate of the turning point of C, this curve here. So it'll be the x-coordinate at the point where this graph is stationary. Now, a technique we can use to find the stationary point is by differentiating the function and working out the x-coordinate where the derivative is equal to 0. Now, in order to differentiate functions where you have powers, we generally use logarithms together with implicit differentiation. And this question has been really helpful in telling us the first step to take. So taking logarithms of the function y is equal to x raised to the x, we get ln y is equal to ln of x raised to the x. I've just taken the natural logs in this case. And using the power law, we can bring this x down to the front, and therefore ln of y is equal to x multiplied by ln of x. Now we can see a function of y on the left hand side and functions of x on the right hand side. Therefore, let's use implicit differentiation to differentiate this function. So first of all, let's start with the right hand side. Here we have a product of two functions, and therefore we can differentiate this right hand side using the product rule, which says that if we have two functions of x, then the derivative would be equal to the following sum of products. So using the product rule, if we let u be equal to x and v be equal to ln of x, therefore u prime, the derivative of u with respect to x, would be equal to 1, and v prime, the derivative of v with respect to x, would be equal to 1 over x. Okay, so you need to know that the derivative of ln x is equal to 1 over x. Using this formula, we have u prime of x times v of x, so that's 1 times by ln of x, and here we have plus u of x times by v prime of x, which is just x times by 1 over x. Here we get cancelling of terms, and so the derivative of the right hand side of this equation is equal to ln of x plus 1. In order to differentiate ln of y, remembering that this is implicit differentiation, so the derivative of ln of y would be equal to 1 over y dy by dx, which I've just placed in these two equations here. in order to find dy by dx, we need to multiply both sides by y, giving us that dy by dx is equal to y times ln of x plus 1. And if you recall from earlier, we were told that y is equal to x raised to the power of x. So we can substitute this into this function in order to get that dy over dx is equal to x raised to the power of x times by ln of x plus 1, giving us a derivative which is in terms of x. Now, in order to find the stationary point, we need to work out the x-coordinate where this derivative is equal to 0. So when dy by dx is equal to 0, we have a product of two functions that are equal to 0. So it's either that x raised to the power of x is equal to 0 or ln of x plus 1 is equal to 0. Now, by looking at the graph, we can deduce from it that the function x raised to the power of x can never actually be 0 on this domain, because you can see it never actually crosses the y equals 0 line. Okay, so they've been very helpful here by showing us how the graph looks, and therefore we can exclude this case, right? So that leaves us with this case, and let's try and solve this to find out x. Here we have ln of x plus 1 is equal to 0. Subtracting 1 from both sides, we get that therefore ln x is equal to -1, and to make x a subject, we need to take e to the power of both sides, giving us that x is equal to e raised to the power of -1. And this would be our stationary point, which you could also work in your calculator as 1 divided by e, okay? And it's 0.36 and so on. Okay, so we can just update the graph to reflect the stationary point that we've just found as around about here. The next part of the question says the point P, which has coordinates alpha and 2, lies on the curve C. Show that alpha is greater than 1.5 but less than 1.6, and this is a 2-mark question. So alpha is the x-coordinate of P that lies somewhere on this curve C, and we need to show that this x-coordinate of alpha is between these values 1.5 and 1.6. So let's see what happens when we substitute 1.5 into this equation. So when x is equal to 1.5, subbing this into this equation, we get that y is equal to 1.5 raised to the power of 1.5, which is equal to 1.8 and so on. And that value is less than 2, which is the y value we get when we substitute alpha into this equation. Okay, so let's just update the graph to show the input of x equals 1.5 and its output. Now, I already calculated earlier that e to the -1 is 0.3 and so on. So x equal to 1.5 would be to the right of this, and its output would be here. Now let's find out the y value when x is equal to 1.6. So when x is equal to 1.6, we get y is equal to 1.6 raised to the power of 1.6. And if you type that in your calculator, you would get 2.1 and so on. And that's greater than 2. Okay, so let's just visually represent that as follows. So we've just found two y values, one which is less than 2 and one which is greater than 2. Remembering that 2 is the corresponding y value of alpha and should be around here. So if we map this y value back onto the graph, we get a corresponding value of alpha that is between 1.5 and 1.6. So we've shown that alpha is between 1.5 and 1.6 by showing that the corresponding y value of alpha lies between the corresponding y values of 1.5 and 1.6. But also a key point to note is that this graph is continuous, and that's necessary in order for us to prove this. Let me explain by example. So here's an example of a graph that's not continuous. Mapping 1.5 to the graph would give us 3, and mapping 1.6 to the graph would give us 5. Mapping alpha to the graph would give us 4, which is between 3 and 5. But here, alpha is less than 1.5 and 1.6. And the domain of this function would exclude values of alpha within this region between 1.5 and 1.6. Because look, any value here can't be mapped to any y value. So a key point of this conclusion of alpha being between 1.5 and 1.6 is that the curve C is continuous. And therefore, we can say that alpha is greater than 1.5 but less than 1.6. Okay. The next part of the same question says a possible iteration formula that could be used in an attempt to find alpha is x sub n plus 1 is equal to 2 times x sub n raised to the power of 1 minus x sub n. And that says x sub n there. It does look a little bit small there. Apologies. Now, the question says, using this formula with x sub 1 equal to 1.5, find x sub 4 to 3 decimal places. Okay, so we need to use this iterative formula and the first term of 1.5 to find x sub 4 to 3 decimal places. So firstly, I'm just going to write this iterative formula here so it's nice and clear for us all to see. Now, starting with our first term of x sub 1 is equal to 1.5. In order to get x sub 2, we need to sub the value of n equal to 1 into this formula, giving us 1 plus 1, which would give us that x sub 2. So subbing x sub 1 into this formula, we get x sub 2 is equal to 2 multiplied by the x sub 1, which is 1.5, raised to the power of 1 minus 1.5, which is x sub 1. So let's just pop over to the calculator to work this out. Okay, so let's write it as it is: 2 multiplied by 1.5 raised to the power of 1 minus 1.5 gives us a value of 1.63 and so on, which we can just jot down. Okay, now in order to find the next term, we could follow the same process, but our calculators can do the job a lot quicker, and let's show you now. So what we can do is go back to the place where we substituted in our term, which was here and here, and what we can put in place of these terms is answer. So if we put answer here and we put answer here, we would get the next value. Okay, so the next value is 1.466 and so on. Okay, so let's just write that down. Therefore x sub 3 is equal to 1.46 and so on. And to get x sub 4, all we have to press is equals, as it's now going to take the most recent answer and substitute it in place of this value. So pressing equals, we get that the next value is 1.67 and so on, which is our x sub 4. Now we've been asked to round this to 3 decimal places, so therefore x sub 4 is equal to 1.673 rounded to 3 decimal places. The next part asks us to describe the long-term behavior for x of n. So when you're asked about the long-term behavior, it's a keyword which tells you need to be thinking about what happens to the value of xn for large values of n. It's pretty hard to tell what's going on here, but we know that we can use our calculator to use this function repeatedly to work out what would happen as n gets progressively larger. Okay, so let's press the equal sign and let's keep pressing the equal sign and let's keep pressing it and see what happens. Okay, okay, so look at what happens when we continue to press the equal sign. The values are oscillating between 1 and 2. Okay, so how we can describe the long-term behavior of x of n is by saying that as n goes to infinity, x of n becomes a periodic sequence with order or period 2. Okay, question 12. This question asks us to prove that cosine of 3 theta over sine of theta plus sine of 3 theta over cosine of theta is equivalent to 2 cot 2 theta, for theta not being equal to 90n degrees, where n is an integer, and this is a 4-mark question. Now, as this is an equivalent, we can prove this either from the left to the right or from the right to the left, but it looks like there's a lot more to work with on the left hand side of this equivalent, so let's see how we can work with this left side here. Now, just inspecting the terms, there doesn't immediately look like there's anything we can do straight away with the terms. However, we can add the fractions and see what happens, okay? In order to add these fractions, we of course need to achieve a common denominator. So that means we need to multiply top and bottom of this fraction by cosine of theta, and multiply top and bottom of this fraction by sine of theta, giving us that this sum here, cosine of 3 theta over sine of theta plus sine of 3 theta over cosine of theta, is equivalent to cosine of 3 theta cosine of theta plus sine of 3 theta sine of theta all over sine of theta cosine theta.
The first thing I'd look at is, are there any cancelling terms now that we've added the fraction?
It doesn't appear so. The next thing I'd think about is, are there any identities we know of which can simplify this right hand side? Well, there is an identity, and it's one that isn't used as often for proving trigonometric identities. It's the compound angle formula. Now, comparing this numerator with the compound angle formulas, the one we're going to choose is this one here.
And that's because on the right hand side of this equation we have cos of an angle times cos of another angle, and we have the same here, cos of one angle times cos of another angle, and then we have plus sine of an angle times sine of another angle, and in the numerator we have plus sine of one angle times sine of another angle, and this is all equal to a trigonometric function which looks a lot more compact or simplified.
Okay, and these will be given in your formula booklets. So we have cosine of 3 theta times cosine of theta plus sine of 3 theta times sine of theta. Well, these are different arguments or angles which would represent A and B.
And since we are adding the product of trig functions, once we simplify to an expression of this form, we need to subtract, okay? And how to read this is that the bottom symbol goes with the bottom symbol on the other side of the equation, and the top symbol goes with the top symbol on the other side. All right?
So therefore, the numerator is equal to cosine of 3 theta minus theta. Let's have a look at the denominator. Well, the denominator, sine of theta cosine of theta,
looks like an identity that you're probably more familiar with.
and that's this one here. The sine 2 theta is equivalent to 2 cosine theta sine theta. And looking at this identity, we can see that the denominator, sine theta cosine theta,
would be equal to the right hand side of this identity divided by this 2 here. And if we're dividing this side by 2, we need to divide this side by 2. And therefore, the denominator would be equal to 1 over 2 times sine 2 theta.
Looking at our numerator, we can see that we have 3 theta minus theta inside brackets, which is equal to 2 theta. And in order to get rid of this fraction in the denominator, we can multiply the top and the bottom of this fraction by 2. So this whole expression is equivalent to 2 in the numerator, which we got by multiplying the top and bottom by 2. Multiplied by cosine 2 theta. The 2 theta comes from 3 theta minus theta, all divided by sine 2 theta. And so we can simplify this even further, because we should know that tan of 2 theta is equal to sine 2 theta over cosine 2 theta, and therefore the reciprocal would be equal to cot 2 theta, and therefore this expression is equivalent to 2 cot 2 theta, which proves the result. The next part of the question says, hence solve for values of theta between 90 and 180 degrees the equation cosine of 3 theta over sine of theta plus sine of 3 theta divided by cosine of theta is equal to 4, giving any solutions to 1 decimal place. And this question is for 3 marks. So as it says hence, we'll use what we've found in the previous question to solve this problem. Now the left hand side of the equation is equivalent to what we've just proved to be 2 cot 2 theta. And therefore we can say that 2 cot 2 theta is equal to 4 and work to solve this equation. So dividing both sides by 2, we get that cot 2 theta is equal to 2. When solving trig equations, you always want to try and convert these reciprocal trigonometric functions into the standard sine, cosine or tan. So we know that cot 2 theta is equal to 1 over tan 2 theta, and therefore
let's write that 1 over tan 2 theta is equal to 2. Taking the reciprocal of both sides of the equation gives us that tan 2 theta is equal to a half.
And I've taken the reciprocal here just so we can get the tan 2 theta equals to a value instead of having it in the denominator.
To solve this equation, we first of all take the inverse tan of both sides to get that 2 theta is equal to tan inverse of a half. And we're going to use a cast method to solve this problem. Using this method to work out the principal solutions of this angle 2 theta. So observing that tan 2 theta is equal to a half, well, this tells us that tan of an angle is equal to a positive value. And therefore our reference lines would fall in the all quadrant where all angles are positive and the tan quadrant where only tan is positive. We can now work out our reference angles by calculating this value here, tan inverse of a half. So using the calculator, tan inverse of a half, 1 over 2, is equal to 26.56 and so on. And we always draw the reference angles from the x-axis towards the reference lines, and therefore both of these angles would be equal to 26.5 and so on degrees. Now because we have one of the reference angles which falls within the all quadrant, that means that we can take this angle immediately to be one of the principal solutions equal to 2 theta, and we then need to calculate what this angle would be, which is from the positive x-axis all the way to the reference line. And hopefully you can see this angle would be 180 degrees plus this angle which we calculated to be 26.5 degrees and so on.
So adding them together would give us our other principal solution.
And therefore 2 theta is equal to the first principal solution being 26.56 and so on degrees, and our other principal solution which is 180 plus this value, so 180 plus the value we've just calculated, which is equal to 206.56 and so on. So we now have our principal solutions for this angle 2 theta. Now we need to work out whether there are other solutions in its interval and if these principal solutions actually lie within the allowed interval. Now because we are solving a trigonometric equation where the angle is being multiplied by a value, we need to be careful as this would cause the bounds to change. So let's figure out what this interval would change to by using the change of bounds method. So using the initial interval we were given, if theta is bounded by 90 and 180 degrees, therefore 2 theta would be bounded by 2 times 90, which is equal to 180 degrees, and 2 times 180, which is equal to 360 degrees. Okay, so this tells us the bounds that we can work within given our angle of 2 theta. In order to get other solutions that may fall within the interval, we need to add the period to these principal solutions. And you should recall that the period for tan is 180 degrees. So adding 180 degrees to 26.56, well, if you remember, that's what we did earlier on to get this value. And let's just do that again. So the value here, 26.56 and so on, plus 180 degrees, just gives us this value. Add 180 degrees, we get 386.5 and so on degrees. And that would fall outside of this region. And so we can't use this as another solution that satisfies the interval.
So now if we investigate our principal solutions,
the only solution that falls within this range is this one here. So since 2 theta is equal to 206.56 and so on, therefore theta is equal to 206.56 and so on divided by 2, which is equal to 103.28 and so on degrees. And as we've been asked to round the solution to 1 decimal place, the final answer is that theta is equal to 103.3 degrees to 1 decimal place.
Question 13. A manufacturer produces a storage tank. The tank is modelled in the shape of a hollow circular cylinder closed at one end with a hemispherical shell
at the other end as shown in figure 9. So here in figure 9 we've got this storage tank, and on one end we have this hollow circular cylinder, which is here, and on the other end we've got this hemispherical shell, which is here at the top. The walls of the tank are assumed to have negligible thickness. The cylinder has a radius of r meters and a height of h meters, and the hemisphere has a radius of r meters. The volume of the tank is 6 meters cubed. And part A asks us to show that according to this model, the surface area of the tank in meters squared is given by the following expression: 12 over r plus 5 over 3 pi r squared. And this question is for 4 marks. So using the information given in the question, we need to find an expression for the surface area of this tank. And if you look at this tank, you'll see that the surface area of the tank is made up of different parts. One part is the circular base, another part is the curved surface, which forms a cylinder shape, and the other part is the hemisphere. So if we let S be equal to the surface area of this tank, then S, the surface area, is equal to the surface area of the circular base plus the curved surface area of the cylinder plus the surface area of the hemisphere. So given the information we have in this question, let's try and work out expressions for each of these surface areas. So starting with the surface area of the circular base, we've been told that this circular base has a radius of r meters, and therefore the surface area would be pi r squared. The curved surface area of a cylinder, well, if we have a cylinder of radius r and height h, well then the curved surface area would be equal to 2 pi r times by h. And finally, the surface area of a hemisphere, well, a hemisphere is just half of a sphere. And in this question, we've been told that a sphere of radius r has a surface area of 4 pi r squared. And since a hemisphere is half of a sphere, that means the surface area of the hemisphere would be half times 4 pi r squared. We can cancel down the 4 and the 2's, giving us 2 pi r squared. And here we have two like terms, pi r squared and 2 pi r squared, which we can collect. So therefore S is equal to 3 pi r squared plus this 2 pi r h, which we'll just label this as equation 1. So let's take a look back at this expression that we've been asked to show, and let's compare it with the one that we've just found for the surface area. Are they the same? Quite clearly not. Now coming back to this one, you can see here that the only variable inside this expression is r, whereas here we have r and h. So we have to try and find a way to express h in terms of r, which is the most logical step to take towards showing this expression. And in show that questions, I would advise that you use every bit of information that's provided in the question. One bit of information we haven't yet used is that the volume of the tank is 6 meters cubed. We also know that the volume of this tank is equal to the volume of its parts, which is the volume of the cylinder plus the volume of the hemisphere. So we know the volume of the tank is 6 meters cubed. We can also find another expression for the volume of the tank by adding the volume of the cylinder to the volume of the hemisphere. And based on this, we can generate an equation. As we know the volume of the tank is 6 meters cubed, we can say that 6 is equal to the volume of the cylinder, as it's got a radius of r and a height of h. Therefore, the volume of the cylinder would be pi r squared h, plus the volume of the hemisphere, which is half the volume of a sphere. And in the question, they've told us that a sphere of radius r has a volume of 4 over 3 pi r cubed. And therefore, a hemisphere would have a volume of half times by 4 over 3 pi r cubed. Multiplying this fraction gives us 4 over 6, which simplifies to 2/3, and therefore 6 is equal to pi r squared h plus 2/3 pi r cubed. Let's now make h the subject of this equation, which would give us an expression for h in terms of r. So if we subtract 2/3 pi r cubed from both sides, we get 6 minus 2/3 pi r cubed is equal to pi r squared h. Now if we divide pi r squared from both sides, we get that 6 pi r squared minus 2 pi r cubed over 3 pi r squared is equal to h. And here we get the pi's cancel, and r cubed over r squared is equal to r in the numerator. And therefore h is equal to 6 over pi r squared minus 2r over 3. So we now have an expression for h in terms of r. Let's now substitute this back into equation 1 and see if we're then able to achieve this expression. So subbing h back into equation 1, we get the S, the surface area of the tank, is equal to 3 pi r squared plus 2 pi r times by 6 over pi r squared minus 2r over 3, which was our expression for h. Multiplying out the brackets, we get that this is equal to 3 pi r squared plus 12 over r. We get the 12 by multiplying 2 and 6. The pi's would cancel, and the r we get in the denominator comes from multiplying this r by 1 over r squared. Multiplying 2 pi r by negative 2r over 3 gives us
Negative 4 pi r squared over 3.
Collecting the like r squared terms gives us a final answer of 5 pi r squared over 3 plus 12 over r as required. The next part says use calculus to find the radius of the tank for which the surface area is a minimum, and this question is for 4 marks. Now we know that the surface area is equal to this expression here, 5 pi r squared over 3 plus 12 over r. Now to be honest with you, I'm not quite sure why I've written it the other way around, but it doesn't matter, does it? Because addition is commutative. Now we can look at S, the surface area, as a function of r, and we know how to use calculus to find the minimum and maximum of a function. What we do is differentiate that function and set it equal to 0. So let's go ahead and do that. First of all, I'm going to rewrite this 12 over r as 12 times by r raised to the negative 1, and this will make it easier to differentiate. And therefore, the derivative of s with respect to r is going to be equal to, well, differentiating this part, we get 2 multiplied by 5 over 3, which is 10 over 3, and we subtract 1 from the power, so we get 10 over 3 times by pi r. And here we need to do the power minus 1 multiplied by 12, and then subtract 1 from the power to get minus 12 r to the negative 2.
So in order to get that value for r for which the surface area is minimum,
we need to set this function equal to 0. So as mentioned before, we know that the minimum exists when the derivative ds over dr is equal to 0. So we need to set this function equal to 0, and that will allow us to work out the value of r, the radius for which the surface area of the tank is a minimum. So setting this equal to 0, we get 10 over 3 pi r minus 12 over r squared is equal to 0. And I've just rewritten 12r to the negative 2 here as 12 over r squared. We can now subtract these two fractions. So in order to achieve a common denominator, we need to multiply the top and the bottom of this fraction by r squared, and the top and the bottom of this fraction by 3.
after you get your common denominator, you can then subtract the numerators to get that 10 pi r cubed minus 36 over 3r squared is equal to 0.
By multiplying both sides of the equation by 3r squared, we then get that 10 pi r cubed minus 36 is equal to 0. Adding 36 to both sides, we get 10 pi r cubed is equal to 36. Dividing both sides by 10 pi, we get that r cubed is equal to 36 over 10 pi. Working this out in your calculator, you get that r cubed is equal to 1.14 and so on. And taking the cube root of both sides, we get that r is equal to 1.04 and so on meters. The last part of the question says calculate the minimum surface area of the tank, giving your answer to the nearest integer. And this question is for 2 marks. So having just calculated the radius, which gives us the minimum surface area, all we need to do is substitute this value into our equation for the surface area to get the minimum surface area. And therefore the minimum surface area S min is equal to 5 pi times by 1.04 all squared, so just subbing this value in and squaring it as per the equation, divided by 3 plus 12 over r, which is equal to 1.04 and so on. Subbing this into our calculator, we get 17.20 and so on. And as we've been asked to round to the nearest integer, it follows that the minimum surface area is equal to 17 meters squared rounded to the nearest integer.
Question 14 and the final one of the paper. Part A asks us to use the substitution u is equal to 4 minus the square root of h to show that the integral with respect to h of this function 1 over 4 minus the square root of h is equal to negative 8 ln of 4 minus the square root of h minus 2 root h plus k, where k is a constant. And this question is for 6 marks. So for this question, we need to integrate this function by substitution and show that it's equal to the right hand side. So we have this integral here, and we've been given a substitution of u is equal to 4 minus the square root of h. Now, the idea of integration by substitution is to convert the integrand in its current state into something that's easier to integrate, basically. So our objective in this case is to convert the integrand from h's and dh's to u's and du's. Okay, so keep that in mind. Now, the substitution that we've been given in this question to work with is u is equal to 4 minus the square root of h. You can see here that I've put a box around it and labeled it. This is something I do for every integration by substitution question, because for many of the tricky ones, you often have to refer back to the substitution equation you're using. So using our general steps for this method, we next need to differentiate u with respect to h. So first I'm going to rewrite the square root of h as h to the power of a half. And now we're going to differentiate 4 minus h to the half. And therefore, du by dh is equal to negative half multiplied by h raised to the power of negative half. The next stage of this method is to make dh the subject of this equation. In order to get rid of this negative half, I'm going to multiply both sides of the equation by negative 2 to get negative 2 du over dh is equal to h raised to the negative half. By the way, as long as your operations are mathematically correct, you can rearrange in any way you wish to make dh the subject. Next, I'm just going to rewrite h to the negative half as 1 over the square root of h. We can then cross multiply to get that dh is equal to negative 2 times by the square root of h du. So now that we've made dh the subject, let's substitute the expression we now have for it back into the integrand, and then after that we can analyze what we have to do left in order to achieve our goals of converting these dh's and h's into u's and du's. Okay, so substituting this into the integrand, we get that the integral of dh over 4 minus the square root of h is equal to the integral of minus 2 root h du over 4 minus the square root of h. And all I've done here is I have substituted dh in the numerator for this negative 2 square root of h du that we've just worked out. Now looking at the integrand, we can see that we still have some h's that we need to convert into u's. If you look at the denominator is 4 minus the square root of h. And if we look back at our equation 1, we know that 4 minus the square root of h is equal to u. So we can substitute that straight into the denominator. And therefore we can say that this is equal to
the integral of minus 2 root h over u du, substituting the denominator for u.
Now lastly, we notice we have negative 2 root h in our numerator.
Now if we look again at this equation,
I hope you can see that you could rearrange this equation to make the square root of h to be the subject. And this is what you would get. The square root of h is equal to 4 minus u, giving us an expression for the square root of h in terms of u. We can now substitute this for the square root of h to get the integral of negative 2 times 4 minus u over u du. So by using this method, we've managed to convert from h's and dh's to u's and du's. I'm going to now simplify this to show you that it's truly easier to integrate. So multiplying the brackets in the numerator, we get the integral of minus 8 plus 2u over u du, and this is equal to the integral of minus 8 over u plus 2, all with respect to u. And now we can integrate these terms. So the integral of minus 8 over u with respect to u is equal to minus 8 ln u, and the integral of 2 with respect to u is 2u. Don't forget to add your constant of integration. The next step we need to take is we need to substitute 4 minus the square root of h back into u
for the integral we've just worked out.
So this is equal to minus 8 ln of 4 minus the square root of h plus 2 multiplied by 4 minus the square root of h plus c. Expanding the brackets out, we get minus 8 ln of 4 minus the square root of h plus 8 minus 2 root h plus c. Taking a look back at what they've asked us to show, we have the same term here, minus 8 ln of 4 minus the square root of h. We also have the minus 2 root h here. And as you notice, there's a plus k here, but the k just represents a constant and can be any constant really. So 8 plus c can be expressed as k, and therefore this is equal to minus 8 ln of 4 minus the square root of h minus 2 root h plus k as required. The next part says a team of scientists is studying a species of slow-growing tree.
The rate of change in the height of a tree in this species is modeled by the differential equation
dh over dt is equal to t to the power of 0.25 multiplied by 4 minus the square root of h over 20, where h is the height in meters and t is the time measured in years after the tree is planted. Part B asks us to find, according to the model, the range in heights of trees in the species. And this question is for 2 marks. In order to calculate a range for the heights, we need to think about the minimum and the maximum possible values that the height can take. Starting with the minimum, the height is a positive quantity and can't be less than 0, so therefore h must be greater than or equal to 0. And if you gave your answer as h strictly greater than 0, you would have got the mark for this question. What they're trying to test is that you are thinking about the range of possible values of certain quantities, and that you would notice that h must be positive. Let's work out the maximum value of h now. Notice that h, the height, would change over time, and that means that h is a function of time. We've seen in a previous question that if you have a function, you can find its maximum value by taking its derivative and setting it equal to 0. In this case, we've been given the derivative of h with respect to t as follows. So we can find the maximum height by setting this derivative
dh over dt
equal to 0. Therefore, t to the power of 0.25 times by 4 minus root h over 20 is equal to 0. So let's solve this for h to find the maximum height. So multiplying both sides by 20, we get t to the power of 0.25 times 4 minus root h is equal to 0. Here we have a product of functions which is equal to 0, and therefore t to the power of 0.25 is equal to 0, or 4 minus the square root of h is equal to 0. We could solve both of these equations, but we don't need to solve this equation because we want to find
the maximum height. So solving this equation, we need to add the square root of h to both sides, which gives us 4 is equal to the square root of h, and then taking the square of both sides, we get that h is equal to 16, and that's the upper bound or the maximum value. So therefore, the range of heights is all values of h greater than or equal to 0, but less than or equal to 16. In the final part of this question, we're told that one of the trees is 1 meter high when it is first planted. According to the model, part C asks us to calculate the time this tree would take to reach a height of 12 meters, giving your answer to 3 significant figures. And this is the most meaty question with 7 marks. Remember in the previous question I said that the height was a function of time. So if we're able to find the general equation which links the height with the time, then we can work out the time if we know that the height is 12 meters. Given this equation, dh over dt is equal to t to the power of 0.25 times 4 minus root h over 20, we can work out a general equation linking h and t by integrating this using the separation of variables method. So here we have the equation above, and by using the separation of variables method, we need to get the h's and dh's on one side and the dt's and t's on the other side. And this can be done as follows. How I've done this is I've divided both sides by 4 minus the square root of h, which gives me the 4 minus root h here on the left hand side in the denominator. And I've multiplied both sides of this equation by dt. And that's where we get the dt on this side. So now we've separated the variables, we need to integrate both sides. So integrating the left hand side with respect to h, we notice that this is the same function as we had above, and we know it's integral. So we can write this on the left hand side, and notice that I haven't included the constant k. When you are integrating by separating variables, it doesn't matter which side you have your constant on, as long as it's there. I'm going to put the constant on the right hand side of this equation. Okay, so now let's integrate the right hand side with respect to t. So here we need to raise the power, which gives us 1.25, and then we need to divide by 1.25, and that gives us 1 over 25 times by t raised to the 1.25 plus our constant of integration. Now in order to find the general equation linking h and t, we need to work out what this constant of integration is. And here we've been given in the question that one of these trees is 1 meter high when it was first planted. So we've been given some initial conditions that we can use as values inside the equation to work out the value of c. By interpreting this, when t is equal to 0, h the height is equal to 1. So subbing these values into this equation, we get the following. On the left hand side, we get minus 8 ln of 4 minus 1. The square root of 1 is just 1 here, minus 2 times by 1. And that's equal to 0, which we get from subbing t equals 0 into this. So 0 raised to the 1.25 is 0 times by the 1 over 25 is 0 plus our c. And evaluating the left hand side, we get that c is therefore equal to negative 8 minus ln 3 minus 2. So now we have a value for c. Let's sub it back into our first equation, and therefore minus 8 ln of 4 minus root h minus 2 root h is equal to 1 over 25 times t to the power of 1.25 minus 8 ln of 3 minus 2. So now we have our general equation linking h and t. We can work out the value of t when the height is equal to 12 meters. So let's sub h equals to 12 into this equation, and we get the following. Minus 8 ln of 4 minus root 12 minus 2 root 12 is equal to 1 over 25 times t raised to the 1.25 minus 8 ln of 3 minus 2. We can move these terms to the other side of the equation by adding 8 ln 3 plus 2 to both sides, and therefore we get 1 over 2 times t to the power of 1.25 is equal to minus 8 ln of 4 minus the square root of 12 minus 2 root 12 plus 8 ln of 3 plus 2. Okay, so be careful of the sign change. We can now work out the whole of this right hand side in our calculator. Let's go ahead and do that right away. So we have minus 8 ln of 4 minus the square root of 12 minus 2 root 12 plus 8 ln of 3 plus 2. Pressing equals, we get 8.85 and so on. And therefore, let's just jot this down. So 1 over 25 times t raised to the 1.25 is equal to 8.85 and so on. We then need to multiply both sides by 25. So multiplying 8.85 and so on by 25, let's just do this in our calculator. So multiplying this value by 25, we get 221.27 and so on. And therefore, t to the power of 1.25 is equal to 221.27 and so on. To calculate t from here, we need to take the 1.25th root of both sides of the equation, as you see here. So let's just work this value out in our calculator. So we're going to press shift, press this button here. We're going to do 1.25, and here we're going to put in answer, which is the answer we found here, 221.27, so on. Pressing equals, we get a value of 75.15 and so on. So therefore t is equal to 75.15 and so on. So since we were asked to calculate the time giving our answer to 3 significant figures, rounding this value, we get that t is equal to 75.2 years to 3 significant figures, and don't forget your units, okay? If you like this video, please give us a thumbs up, leave your comments down below, and subscribe to this channel so you'll be the first to know when we release our next videos.